Hello everyone, TorqueMod here. In today's quick tutorial, I'm going to show you guys how I solved an issue that I was having with the player camera. So in a third-person template with camera boom, uh, you have the option of setting a target offset, which I've set to be 150 on the y-axis, which is basically shoving my character to the left side of the screen. So you've got more of an over-the-shoulder, Gears of War style camera view. The issue with this is depending on the direction, as long as you're moving, forward, right, backwards, and right, you're fine. But as soon as you start going down, left, or up and left, your character gets cut off, and that's less than ideal. So what I'm going to put together for you, I'll just pause the video and show you what it looks like. So what I've coded here is a system to dynamically adjust the socket offset based on the movement. So now when we're going to the left or we're going down, the character stays basically in the same area of the screen. And when you stop, it smoothly transitions back to its default value. So let's take a look at the code. So if we go into the character that I've been building here, there's nothing really that different with this setup. It's a regular third-person character based off of the Unreal 4 blueprint template. I have adjusted the camera boom so that it's up at 75. I prefer the boom to be level with the shoulders as opposed to the center of the capsule. And our default value for the socket offset is actually at 0 because I'm changing that dynamically on tick. And the target arm length I've set to 250. So now if we take a look, I separated the input into just another graph that I named an input graph. So if you're wondering, you've never seen an input graph before, you can literally create your own graphs here. That's the Johnny graph now. So just to give you an idea of how that functionality works. Anyways, so I've got the input graph here. And the first task was to get the value of the X and Y and convert this into a degrees, basically. If we were to look at a compass here, so I wanted 0 degrees to represent north or moving forward, 45 northeast, etc., all the way around to 359, basically, without it outputting negative values, because Unreal loves to do that. When you don't do the conversion, if you're running down, it turns it into a negative 180, and to the left becomes a negative value as well. So I created a function to handle this. So in my function, I've got, I named it convert movement to degrees and calculate offset value. I like my function names to be very verbose. So I've put a little note here that this needs to be run on tick. And I've also included an example of the input directions being mapped to cardinal degrees. So same as the compass image I showed you in Photoshop, north, south, etc. So basically, what we do is we want to get our directional input. Now, how you do that is based on the enhanced input. So it depends obviously on what you're using. But in enhanced input, I've created an input action called, in this case, I'm working on building a template. So a multiplayer dungeon crawler input action underscore move. And that's literally just using an axis 2D, and otherwise nothing changed. So once you've done that and you've set it up to be using the enhanced input to drive your movement, these X and Y values are accessible by simply right-clicking. And in this case, I just type in input and then MP because that's what I named all of my input actions. And where you see enhanced action values, so this is how you grab the value of the input action. So you don't have to try and calculate this on tick or anything like that. Every time you press a different movement key, these values will automatically be updating, and anytime you're holding down any of the movement inputs, it's essentially running this on tick anyways. So we grab our move value, which is a vector 2D, and then we just split it here. And so that's how I got this node for getting the directional input. Now, there is this node called a tan2 degrees. And when you type in a tan2, you can choose degrees or radians. If you choose radians, you're going to have to do extra math to convert it into degrees anyways. So I just went directly to degrees. And if you were to hook these in the way it asks for them, with Y on top and X on bottom, it actually means that the X value is 0. So when you're holding D, that's when you get 0. So it would rotate your entire compass basically 90 degrees. So because I didn't want that, I just plugged them in directly. And that sets it up so that you've essentially mapped all of your directional values into this sort of range. Then, if you were to preview, we were to do a print string off of this, you'd actually see that these values are outputting negative. As I was saying, when you go down or left, it becomes a negative value. Same thing with northwest. And so, sorry, I'm just going to OCD. So then you have to convert it into positive values only. So we take whatever the value is, we add 360, and that's just a regular add node. And then you get the modulus of 360. So modulus. So if you type in mod, you might see it, but the easier thing is to just do the percentage symbol. So, and of course it's not even telling you that that's a modulo. But anyways, if you hit percentage, and we're doing it from float, then we're typing in 360 here. That's actually going to output our 0 to 359. And then once you get past 359.9, it goes back to 0 again. So that's how we convert our directional input into degrees. And then all I'm doing is, oops, I probably shouldn't have closed that compass image. But what I'm saying is any of the values between 0 and 135, which is moving southeast, Anytime the values are in that range, I want to return a value of 1. And anytime they're not in that range, I want to return a value of 0. And I use this to modify the, the socket offset amount. So I think actually I've got an extra variable there that I didn't need. So if we go back to the compass here, just to give you a more obvious division. So in this range, basically I'm saying everything in here I want to return a positive 1 value. Let's put that there and multiply. So basically, any of these directions are going to return 1, and any of these directions are going to return 0. So that's what I was trying to illustrate with this. Unfortunately, with comment boxes, you can't do diagonals, so it looks a little bit more janky there, but hopefully it makes sense. So the first thing, the next thing that I want to do, is that if you are moving down, i.e. the value is 180 degrees, then I actually want the value to be half. And the reason for that is if you leave the value at full when you're running down, it actually makes your character go back into the center of the screen. So I played around with the value and found that half seems to be pretty accurate. So if we look here, when I'm pressing down, he's still roughly in the same space. He shifts a little bit more. So I might even do like, 0.35 or 0.4 to get it to be pretty much exactly in the same spot. But he's within these two these two checkerboard squares, right? So it's not too much of an issue if you ask me. So anyways, so that's saying if we're moving south, so this is saying check the value, whatever the input value is returning. So if it returns a value that is nearly equal, so we just type nearly, and you'll get nearly equal float. So if it's nearly equal to 180 with the tolerance of 5, so the tolerance meaning if it returns 175 or 185, it's still going to consider that 0. So it's for the thumbsticks if you're using a gamepad. If you're using keyboard, when you press S, you're always just going to get exactly on 180. But if you're doing the thumbstick, that just allows a bit of drift there, which is what the error tolerance is doing. So if it's nearly equal to 180 within a range of 5 degrees, then I'm setting an out target value, which is just a float, to 0.5. So how I did that is on the function in node, you just create an output, call it out target, give it a value of float. The other thing you can do is if you just type in a return and you get add return node, imagine that this out target wasn't here. Well, if I just grab this and plug it in like that, when it's got the check mark, not into the box, but into the node itself, it'll just add an extra output value. So that's another way to do it quickly. So if we are moving south, give it an output of 0.5. If not, then we check our range. So this is the range from 0 to whatever this value is. So from 0 to 135, if it's within that range, then we're going to output 1. And in all other cases, it means it's going to be between 136 and 359.9. Then we're going to return a value of 0. So once we've done that, that'll actually give us the correct values that we want. Then we have to do a blend. And so normally with blending between floats, you would use something like a linear interpolate, for example. Well, a lerp node only works when you've got an alpha. So if we look at a lerp here, our alpha value will switch between these two values that we plug into A or B. The problem is your input, when you're on a keyboard, if I'm holding D, my value on the X will be 1. But as soon as I let go, it snaps instantly back to 0. It doesn't blend back to 0. So you can't use a lerp. If you wanted to use a lerp, you would have to set up a timeline or timer event, and it just gets really, really messy. So we have a node to handle that, which is the interp2 node. So I created another functional called smooth blend target value. So basically the out target, if we look at the input graph here, so the out target here coming from our function of convert movement to degrees is then getting fed into the in value of my smooth blend target. So if we look at the smooth blend target, here's the target, and this is the finterp node. So this is taking in the value of our degrees for the direction, so basically anywhere between 0 and 135. And we're setting that as our target value. And then you want to create just another variable called smoothed value. You can name it anything you want, but to me this is the easiest way to make sure that if you're coming back to an interp node and you're looking at it again, you can understand instantly what is going on here. So I just created another float. I called it the smoothed value, and you use that as your current. You use the world delta seconds, which is essentially finding the amount of time between frame generations. So your tick rate, and you're plugging that in. So again, you just right click, get world delta, and you'll see get world delta seconds. So we plug that into the delta time. And then the interp speed here, the higher the number, the faster the blend between these two values will be. And the lower the number, the longer it'll take. So I've written a little bit of a note here. The interp speed determines how quickly the blend happens. Lower values equal slower transition. 10 seems to be about 1 second when I just counted in my head. 20 would be half a second. 5 would be 2 seconds, etc., etc. So if you want the easing to take a little bit of time, then you want this to be a lower number. I could even go from 5 to maybe 2, and it might make the transitions a bit smoother, but for now 5 was okay for me. And then whatever that new value is between the original value and the target value, then you're going to set this to be the new smooth value. And that is how you get it to update. So when I'm holding D, the value will be 1. And when I let go of D and I press, or if I let go of D and I stop, the value will blend back to 0. So over, basically 2 seconds. And then we take that value and we give another output. And this time I just called it output blend because it lets me know that this is the blended value that I've blended through an interpolation. And then back to my input graph, then I just hook these up to a tick. So I did a custom event called tick camera boom socket offset. The reason I plugged in a custom event here is you can only have one event tick in any blueprint. And if I put it in the input graph, it's just harder to find. Usually you want your event tick to be in the event graph. So I have my event tick in the event graph, and I just tell it to call this tick camera boom socket offset every tick. And so then that means every frame it's going to be checking our values, and then it's going to be blending our values. And then finally, what we do is after running these two functions, I multiply that amount because I've turned this into either 0 or 1. Actually, it outputs either 0, 0.5, or 1, right? And so it's either going to be multiplying whatever the socket offset here. So again, that's this socket offset here. If we set this to 150, just to give you an example of what it looks like. So that means it's pushing the camera to the right, which has the side effect of making your character look like they're standing on the left if you were to just draw a straight line out from the side of the camera there. So that's where I determined my value that I wanted. But we don't want to set it. Well, I mean, you can set it. It won't make a difference because it's happening. The first frame that's generated is going to set it based on the input values. So back at the input graph here. So then we're multiplying that number by whatever my desired amount is. And so I specifically just called this socket offset Y. You could just punch in your number here. So you take whatever your blended value is and you multiply it by 150. So if the blended value is 0, well, 0 multiplied by anything gives you 0. So on that side of the directions, it returns nothing, which means no offset. If it is 1, so anywhere between 0 and 135, then it's going to give us the full 150. And when we're moving down or south, it's going to get us 0.5, which is 75. And that's what controls the dynamic shifting of the socket offset. So then I just grab the camera boom here. I drag out and I choose set offset. And we choose set socket offset. You can also set a target offset if you want, but that's not useful because it ends up making like an elliptic movement around your character instead of a perfectly smooth circular one. But anyways, you set the socket offset, and then you split this, right-click and split struct pin to get the X, Y, and Z values. And we know we want it in Y because that's the number that I had to adjust. And I know this one's Y. I mean, you've always got X, Y, Z, but also if you just click on this drop down, it'll actually tell you the label for each one of these numbers. So if we typed in 150 here, you'll see that that shows up as the Y value. So we want to do that, and then you drag in your value here into the Y offset, which is what I already did up there. And that is how we dynamically adjust the socket offset amount. Now, the reason why I created this as a variable is because this is what's called a magic number. It means if somebody else were to come and look at your blueprint code, or if you didn't look at this code for 6 months and you come back, you're going to be like, why am I multiplying by 150? That doesn't immediately makes sense. So this, you always take these and promote them to a variable so that they're no longer a magic number. So you can give it a name, socket offset Y, and then, you know, somebody looking at this can go, oh, okay, I'm setting the socket offset. There's the socket offset Y, and I'm setting it to 150 times whatever this output blend is. So it just makes it cleaner. And you can, of course, always give a description as well if you want to have a longer description up here, but I'm not going to bother doing that. So anyways, guys, hopefully this can be of benefit to some of you. So final look, now that we've got this happening, you'll see those nice smooth blends when I stop moving. And if we were to adjust the value of our lerp speed here, let's set it to 1, and that'll be much slower. So now you see how it takes a while for the camera to slide into position when we hit play. So it starts at 0 and then it slowly slides over. So that might be what you want, might not. Personally, I think that takes way too long. It seems to be about 4 seconds. So I'm going to go back up and set it to maybe 3 or even 4. And then you'll see that transition. Sorry, I'm used to working with multiple monitors. So then you'll see the transition of moving from 0 to the left, from center to the left, sorry, is a lot faster. And it also means that it's going to transition out. When your character stops running to the left, you'll see that it slides over. But honestly, even that's too slow. So anyways, hopefully this has been helpful for you guys. If you like the video, be sure to hit the like button. And if you haven't done so already, hit the subscribe button too, because it helps with the algorithms. All right, guys. Have a great night. Bye for now.